So in my video today, I'm going to look at the structure of metals. Now metals have what we call a giant metallic lattice. And to do this, I'm going to model this using polystyrene balls, as you can see, this wooden triangle just to hold the shape, and an OHP. Now I've put in the first set of atoms, and obviously you can see that they're arranged in rows. Now, looking at the amount of space that comes through, we're going to look for the amount of light gets through. Now, this is the first layer, and if you can see the amount of light that gets through, the light gets through in the gaps between the atoms. I'm now going to add the second layer. Now, as you can see, I've added the second layer, and again, this forms, as I said, a layer. The atoms are in a regular arrangement, just like with the first layer. Now, let's see the effect on the spacing. Now, this time, as you can see, the amount of light getting through is very much reduced, and the reason is because the atoms of the second layer sit in the gaps in the atoms of the first layer. I'm now going to add the other layers, the third. Now, as you can see, the third layer is added. Again, it's in a layer because the atoms are in a regular arrangement. And let's look at the amount of light getting through. Now, the amount of light getting through is negligible now because the atoms in the third layer sit in the atoms of the second layer. And we said this was called close packing. I'm now going to add the final layers, and let's have a look at what this final structure looks like. Now, this is with all the layers on now, and as you can see, we've got a regular arrangement of atoms. We've got faces, and this is why it's called a giant metallic lattice, because all the atoms are in regular positions. Now, let's try and explain some of the properties of atoms. Now, in this, we know that metals are flexible, and the reason for that is because the fact that the metals are in layers, they can slide past each other. Also, metals are shiny. As you can see, the metals structure has faces, so they can reflect the light. Other properties, they are high density because the atoms are very closely packed, there's very little space, so they're high density. Now, what we can't show from this model is how the electrons are arranged. Now, the electrons in a metal, we say, are delocalized. What that means is that the metal lets its outer electrons roam throughout the lattice. And this lattice is held together by the attraction between the metal ions and the electrons. And because it's an attraction, it is a very strong bond. So, to melt metals, you have to have a lot of energy. So metals have high melting, high boiling points. Also, because of these free electrons, they can roam throughout the lattice, so it can conduct electricity. And also, that will also allow them to conduct heat. Now, one of the issues of metals is that they can be soft, they can be too flexible, if you think of things like aluminium, and the reason is because of the structure. Because it's laid in layers, these cans and rows, they can slide past each other. Now, for a lot of cases and uses of metals, these are properties we don't want. So to change that, let's look at what we can do to the structure. Now, to get over this problem, what we do is to alloy metals. And to alloy metals, we put in a different metal. Now, the effect of that different metal is because it has a different size, it disrupts the rows and layer arrangement. Now the beauty of that is it stops the atoms being able to slide past each other. So as we can see here, the effect on the spacings, they're disrupted so they can't slide past each other. Now if they can't slide past each other, greater force is needed to bend them so they become much harder. And this is one of the ways in which we make alloys, and one of the reasons why we use alloys.